welcome to AMS Talks. I'm your special guest host, Nadia Abboud, and I hope you're ready for an exciting conversation today. I am thrilled to welcome Abigail Cantor, chemical engineer at Process Research Solutions. In this fascinating conversation, Abigail will be sharing valuable insights about a timely project that Process Research Solutions is undertaking with the Madison Water Utility to evaluate real-time monitoring of lead and copper in drinking water systems. The US EPA has recently proposed the Lead and Copper Rule Improvements Regulation to significantly reduce exposure to lead through drinking water to protect children and communities. But here's the catch. The proposed regulation will rely more heavily on using lead and copper monitoring and testing apparatuses that have historically lacked real-time data on water corrosivity. And that's where Abigail's work comes in. So we're excited to learn more about how your project is addressing this challenge and mitigating the risks associated with corrosion. Abigail, thank you again for joining me. Could you share a little bit of background about some of the drivers that spurred this vital research project?
Yeah, thank you, Nadia. The original lead and copper rule became a regulation in 1991. So I've actually been working on these issues since that time. It became very evident to me very quickly that it's difficult to get consistent and representative lead and copper data from a water distribution system. So it's not like setting up an experiment in a laboratory where everything is controlled, the environment's controlled. Instead, we're working in a distribution system where there's many factors that simultaneously influence the release of lead and copper from the piping material into the water. So we've got to make sense of these data and determine what are the significant controlling factors for the lead and copper release. One way to do this is to use apparatuses that represent residential plumbing. And there's several valid configurations of these apparatuses at this time, but it's how you use the apparatuses that can determine your success. And I'll just mention that for more information, listeners can refer to a December 2023 paper in the journal Water Supply, which is a publication of the International Water Association. But back to this topic, all of the apparatus types are sampled manually and only after a 6-hour stagnation period. And this is the critical timing that makes it difficult for a utility to operate an apparatus routinely. So I'll send that back to you.
Now, critical in terms of the timing of resources or in terms of getting data or both?
For getting data, we need to allow a 6-hour stagnation in the apparatus. This is what we actually do when we go to sample residences. This stagnation time is, you can think of it as a reaction time. Like that's when the lead and copper concentrations would be higher than if you had flowing water.
Okay, so then in terms of this research project, when you're looking at exploring the real-time monitoring, what are you doing differently than what's historically been done, and what are the contributions that will have to understanding corrosivity levels for utilities?
So typically, well, like I said, all of these apparatuses are manually sampled. So we have to say, all right, the water's going to flow at such and such a time. I'm going to go 6 hours later and get my 6-hour stagnation sample. Then there's a matter of how much can you afford to send a sample to a laboratory and pay them to analyze for lead and copper. So typically in my project budgets, I can only afford, and my clients can only afford to get one lead and one copper data point once every 2 weeks And then it takes 3 weeks for a laboratory to send me the results.
To which you've had 5 weeks of missing real-time data.
Right. And we only have data points 2 weeks apart, and then we have a lag of 3 weeks to find out what happened 3 weeks previously.
Which must make it difficult to manage the project and really understand what's happening at any given time.
Yes, we'd like to be able to react a lot quicker. There are certain actions a water utility could take if they knew today the lead is releasing higher than it did the day before.
So during this project, will you be using a specific apparatus that is?
Yes.
Yes.
So I developed one of the apparatus configurations that it has a smaller footprint than the EPA described harvested lead apparatus. It has a smaller footprint. It can be placed around a distribution system, so you can see how different zones in a distribution system are reacting to various factors. The harvested lead pipe rigs are very large and very expensive to obtain the harvested test pieces. So here we've got an expedited system where we just said, okay, we want to start. Here's the apparatus. We'll just turn it on, basically.
And some of my understanding of the work that you've been doing throughout these years since the rule came into in the early 90s was understanding that that there's not a detriment to using new conditioned pieces, that it's not essential to have a harvested pipe loop. Is that the?
That's correct. And I referenced that December 2023 paper before, and that paper describes the differences between working with a harvested pipe and working with conditioned new metal.
And how the efficacy really just remains the same.
Right, it really does.
So here you're working with a smaller configuration. You're using the new conditioned pieces, and you've introduced the addition of real-time monitoring. So what was it that drew you to bringing in the AMS MetalGuard real-time samplers for lead and copper for this project?
Before I answer that question, I want to just backtrack and say, even though we're using my PRS monitoring station, whatever we're doing now can be applied to a harvested pipe rig. So
that's really important to bring up. Yes.
Yes. And we'll be describing that in the final report, how you connect to a pipe rig, but it'll all be very similar. So I got involved with the AMS MetalGuard because last year a mutual acquaintance introduced me to Rick Bacon, who is the CEO of the AMS company. And we realized some similar goals and trying to make it easier for water systems to know what the trends of their lead and copper release are and be able to take action quicker. So we came up with this plan to run my apparatus in tandem with the MetalGuards. And right now we do have my apparatus set up in a well house in the Madison Water Utility and connected to the lead test chamber is a MetalGuard that analyzes lead. Connected to the copper test chamber is a MetalGuard that analyzes copper.
So what's next? The equipment's installed, and can you just talk to our viewers a little bit about the project timeline and when you're going to start understanding a little bit more about this?
Well, as we talk, this is week number 2.
Congratulations.
I will be grabbing the first samples tonight and tomorrow. And then we'll be into a routine. After that, we'll go for 24 weeks.
When you
And
say grabbing the samples, Abigail, my understanding is the MetalGuard equipment allows for grab samples and automated samples.
right. So what our goal is to compare the manual sampling to the automated sampling.
Okay.
Now, the way we have it set up for this testing is the MetalGuard is drawing a sample from each test chamber every day, once a day. We could actually draw up to 3 samples every day, taking into account 6-hour stagnation period. But for this test, we are just doing it once a day. Um, Once every 2 weeks, I'm going and grabbing the lead and copper samples in the way I typically do manually. We're going to be comparing those manual results to the MetalGuard's automatically sampled and analyzed results.
And that will be going on for, what's the duration of the research that you'll be taking?
24 weeks.
Okay.
So in September, we'll be finishing up. In addition to comparing the manual and the automatic results, I'm going to visit the MetalGuard twice a week for 24 weeks at the time that it takes the automatic sample.
Mm-hmm.
I'm going to split that sample pour a little bit into a sample bottle and send it to commercial laboratories.
Okay.
And we're going to be comparing the results that the commercial labs get with the MetalGuard results for the automatic sample. So we're comparing the results in several different ways. We're looking for the accuracy of results from the MetalGuard versus the commercial lab, and also the reproducibility. And a final thing we're going to put into this mix is to look at the costs of operating MetalGuard units as well as the monitoring station in tandem.
Well, it sounds like there's going to be a wealth of information available later this year. How are you going to be looking to present that to the utilities across America that are in need of understanding how to put the benefits of real-time monitoring of lead and copper into effect?
Well, first there'll be the official engineering report. We hope to give several presentations at conferences, and certainly write a paper for peer review to assess this approach.
And during these 24 weeks, is there the opportunity for any utilities who are interested in your work to converse with you, come visit, et cetera?
Oh, certainly. They can always
Do you
contact me.
hear that, everyone listening? You're welcome to go visit Abigail.
Yes, they can contact me. I'm going to try to keep graphs of all the different data streams in for comparison.
Okay.
So if people want to keep tabs on this real time, they can contact me.
That sounds great. And I hope you'd be agreeable to come back and speak with me in the future at the close of the project and present the results, because it's very important work what you're doing.
Well, thank you. I'd certainly be happy to.
Wonderful.
I wanted to mention, like, there's 2 really important roles that the MetalGuard plays that hasn't been accessible. The first is the fact that the MetalGuard can take up to 3 lead and copper data points per day, whereas, like we talked about, it takes 2 to 5 weeks to get any feedback. But another very big advantage of the MetalGuard is it's very important to distinguish between dissolved lead and particulate lead, and dissolved copper versus particulate copper. The MetalGuard can actually do that, and there's no other on-site analysis that can do that. So we're very anxious to see how the accuracy and reproducibility of dissolved versus particulate.
It sounds like you've taken a star-studded conglomeration of the test rig, the analysis equipment, with the hope of just bringing a better solution to utilities in need of managing water corrosivity and protecting our communities. So Abigail, I would like to thank you for your time today, and also more importantly for the research and the work that you do to protect the people and our environment.
Well, thank you very much.